Hello, everyone. My name is Aliaksandr Amialchuk. I'm originally from Grodno, Belarus, and I've been working at the University of Toledo for the last 15 years. Toledo in Ohio, in the United States, and I've done this paper with a former colleague of mine who now works at Substance Abuse and Mental Health Center for the federal government. And my research interest is in risky health behaviors of adolescents. I've been researching all kinds of risky behaviors, drug use, through the past 10 years. So this is right up my alley. And so I'm going to talk about the long-term health effects of initiation of marijuana use in adolescence. And so I'm going to give you a little bit of a background on the marijuana use in the United States. I'm going to talk, this is empirical paper, so I'm going to talk about identification. I'm going to use instrumental variable strategy to arrive at the causality, and I'm going to talk about some of the social psychology that underlies the instruments that I use. Then I'm going to present the results and some interesting robustness checks. So I'm going to present some of the things that you might consider doing in your own research if you're thinking about using instrumental variable strategy. So I'm going to talk about marijuana in the United States. So far, last time I checked, we had 39 states, including Washington, D.C., that have legalized medical marijuana use. And then we have 21 states and Washington, D.C. that have legalized recreational marijuana use for adults, 21 over. Ohio is unfortunately not one of those states, so we Ohioans have to travel up to Michigan to get some pot, and it would be nice to have Ohio among those states, strictly for research purposes. But it's coming. So there has been a wave of marijuana legalizations starting for recreational use starting around 2012, and in the roughly past decade, marijuana use among adults has almost doubled. So people are really using marijuana these days. And adolescent marijuana use, while it's illegal, it's still, I don't know how to call it, a big problem, or we are making progress, but it's quite high and it's increasing. So one source suggests that adolescent marijuana use among those who have ever used marijuana increased from 30% in 2016 to 32% in 2018. And if you look, another source suggests among 12th graders in 2016, 22% use marijuana in the past 30 days. That's a lot of kids using marijuana. And 36% of 12th graders back in 2016 have ever tried marijuana. Those are some big numbers. A lot of adolescents report easy access to marijuana, and there is a widespread perception among young people that marijuana use involves minimal harm. When it comes to health effects of marijuana use, well, it's a common perception that marijuana use has some pleasurable effects, which include relaxation, improved mood, increased appetite. I'm not going to ask questions if you guys can relate to those experiences or not, because I realize marijuana use in Lithuania is illegal. But so there is research on the health effects, and there is mostly associational, correlational type of research, and literature finds that regular use of marijuana is associated with depression, anxiety, panic disorder, cognitive and memory deficiencies, problems with perceptions of time and space. Sometimes those problems start right away, and then they go away as you use it more and more. And many of those associations disappear once you start controlling for environmental confounders. So that's where we come in with our econometric tools to ascertain, is there a causal effect of marijuana use on health. We do know that most marijuana use is initiated at young age, probably in high school. So peer influence is probably the major driver. You learn how to use marijuana, you get it from your friends, from your schoolmates. And when it comes to peer influence, it's both observing your friends or siblings use marijuana, as well as perceptions about marijuana use among your peers, and those perceptions might sometimes be biased. So what we do in this paper is we use a large nationally representative data of United States adolescents, which started back in 1994. The data set is very popular. It's called National Longitudinal Study of Adolescent to Adult Health, or abbreviated as AdHealth. So if you're a health researcher, you're most likely familiar with this data set. So it started in 1994, and it continues. So it's a panel survey. It has several waves, and it has a lot of information on health behaviors. And we focus, well, currently the people in this survey are about the same age as I am, and probably most people in this room. I kind of makes it personal to me to look at the what might have happened if I started using marijuana a long time ago, and then my son is here, so what should the message be to the younger generation? So what I do is, we do with my colleague is we look at the effect of initiation of marijuana use at ages 12 to 19, and how that affects some of the mental health indicators roughly 20 years later, when those same people are between the ages of 31 and 42. And in order to arrive at the causal effect, we instrument the adolescent marijuana use with two instruments. One is perception of the adolescent about marijuana use among their friends, and the second is actual use of marijuana by peers. And the outcomes, the health outcomes which we look at, which are measured in the fifth wave of data, which was collected between 2016 and 2018. So one is depression, indicator for whether the person has ever been diagnosed with depression disorder. is based on the question, has a doctor, a nurse, or other healthcare provider ever told you that you have or had depression? Then indicator for anxiety disorder based on the same kind of question. If you had been diagnosed with anxiety or panic disorder. And the third outcome, suicidal thoughts or attempts. If you experienced any suicidal thoughts in the past 12 months, or attempted suicide in the past 12 months. And our main explanatory variable is whether you used marijuana in 1996. It's a binary variable. So whether you used marijuana at least once in the past month or not. And we include a lot of individual level controls, so basic socio-demographic controls like age, gender, race, ethnicity, and family level controls like whether parents have a college degree, whether you have older siblings. Then we include school fixed effects and some other variables, and those controls are important because the way instrumental variable strategy works is that conditional on observable variables which you're able to control for, there is a conditional independence assumption. Instruments are as good as randomly assigned, conditional on those controls. So we use two instruments. The first instrument is the number of best friends whom the respondent perceives to be users of marijuana. It's based on the question asked from the responder: of your 3 best friends, how many use marijuana at least once a month? So regular users among your 3 best friends. And then the second instrument is the proportion of friends who use marijuana. And this proportion of friends is based on questions asked directly to the friends of the respondents. So the data set is famous for being probably the only data set in the United States where students are asked to nominate their school friends, and then within the same school, the survey finds those people, because all people in the school ask the same questions, and you're able to connect the respondent to their friends, and then you can connect those friends to their friends. And we don't want to rely on the friends as the peer group, because that's endogenous, because there is a lot of selection. People select their friends based on preferences and other things. But friends of friends is more disconnected from you. So if your friends of friends are using them, your friends are more likely to use it. And those friends of friends, our restriction is that they're not your direct friends. So you didn't nominate those people directly. It's your friends of friends. So that helps in identification. And so the assumption behind our identification strategy is that after accounting for all the socio-demographic and other controls, observable characteristics, the only way that our instruments, the only way that the number of best friends that respondent perceives to be users, or proportion of friends affect the outcomes, the health outcomes, is through respondents' own use. So that's the exclusion restriction of the instruments.
Sorry, can I ask one quick question? I think I missed it. How do you define friends of friends? Is it based on 3 best friends, or there is another statistics where they list all their friends?
Are you talking about the first?
No, like who are friends of friends?
Oh, friends of friends. Okay, so those are So each person in the survey can nominate friends up to.
All friends, not only three best, all friends.
Right, yeah. So, yeah. So those are different questions. Yeah, yeah. Those instruments are constructed differently. The two instruments are actually related. We rely on literature in social psychology, and one of the famous papers describes sociological model of peer influence on your behavior. So actual peer norm, which would be average use of marijuana among peers, has an effect on your personal use of marijuana, and then your perception about the use of your peers also has a direct effect on your personal use of marijuana. But actual use of your peers might affect your perception. So both instruments have direct effect, but there is also correlation between the instruments. And this is part of the reason why in the main analysis we are using perception as the only instrument. And in a supplemental analysis we include both instruments, because those two instruments are kind of measuring the same thing. I guess the major difference between perception and actual norm, actual use of friends, is the misperception, because people often misperceive how much their friends are using. And the mechanism of relationship between the instruments, the peer use or perception about peer use, and own behavior, own use of marijuana or other drugs, is described, is I guess best described in the famous study by Charles Mansky, the economic analysis of social interactions, where he explains that when you look at the correlation between peer use and my personal use of drugs or any other behavior for that matter, there are three things in that correlation. One thing is the endogenous effect, which is the peer effect. The second is called exogenous or contextual effect, and the third thing is correlated effects. So what are those three things? Endogenous, exogenous, and correlated effects. Well, endogenous effect or endogenous peer effect is the behavioral peer effect, behavioral influence of your friends on you, on your behavior. And for example, if my friends increase their marijuana use or start using marijuana, I will increase my marijuana use or start using marijuana. And we use friends of friends, so there is not much selection in that. And perceptions, we think, are mostly driven by misperception. And so we rely on endogenous peer effect as a source of exogenous variation in the IV. Then the second type of effect is called exogenous or contextual effects, and it's the response of individual behavior to exogenous characteristics of the peer group. For example, older siblings might affect younger siblings' marijuana use just because older siblings' marijuana use increases with age. The older you become, the more likely you're to use. Or if there are parental rules at my friend's home that prohibit drug use, then those parental rules will translate to lower use by the respondent through lower use by his friends. That's another example. Those effects, exogenous effects, are also used as exogenous variation RIV. And the most troublesome effect is called correlated effects. So those are all kinds of selection issues. When people select friends, they select based on maybe common use of marijuana, or maybe based on commonalities of their socioeconomic status. Maybe they're from disadvantaged backgrounds. Or when peers face the same environment, like they go to a school in bad neighborhood, and that bad neighborhood is famous for higher drug use. Or anything else which is shared by the two people who are friends. So those things make our instruments endogenous, because my future health depends on the environment that I grew up in. And that same environment made my friends use marijuana too. So, and marijuana used by my friends is an instrument, so that makes instrument endogenous. And we try to control for this source of endogeneity in the instruments by including a lot of individual level controls and school level fixed effects. Now, the difference between the instruments, the major difference, is probably the perceptual bias in the norm. The perceptual bias about the norm. And there is a paper which is an essentially economics paper, but it relies on insights from psychology, which describes how perceptual bias, which is psychological construct, translates into aggregate behavior and changes in aggregate behavior within a cost-benefit framework. And in this cost-benefit framework, conformity to social norms implies that consumption of drugs will adjust in the direction in which you have a bias. So if you think your friends are using marijuana much more than they actually do, then you're gonna start using marijuana more. Not because your friends are using it a lot, but just because you think your friends are using a lot. So this is the basic cost-benefit framework of how things are in the market for breaking a norm or breaking a law. So demand for so this is demand and supply for wrongdoing, for breaking a norm. In this case, smoking marijuana, which is illegal in adolescents. On the x-axis, we have proportion of people breaking the norm, and marginal benefit of breaking the norm is downward sloping, because if we rank people by amount of benefit that they receive, starting with the high benefit people from breaking the norm to lowest benefit people, we're gonna get this downward sloping demand curve. And supply, it's not upward sloping, because most of the time when it comes to wrongdoing, the more people that have already have broken the norm, the more people that are using drug in this case, the less likely you are to get caught and experience a cost of being caught doing this wrongdoing. And so that kind of safety in numbers implies that the supply of wrongdoing, marginal cost of wrongdoing, is downward sloping. And if we hypothesize a curve like this, then you're going to have at least two equilibriums. Here and here, where this would be a stable equilibrium, so the proportion of people breaking norm will converge to this point, or unstable equilibrium, where On this part, the cost is higher than the benefit. On this part, the benefit is larger than the cost. So if something happens to the system, the proportion of wrongdoers, breakers of the norm, will deviate away from this equilibrium, and number of people breaking the norm will either be zero or it'll converge to the stable equilibrium. So that's the basic cost-benefit framework. And then if you introduce the bias, perceptual bias, into this framework, bias is when you think more people engage in this behavior than actual. So if we start with the actual equilibrium, so this would be the actual marginal cost, the true marginal cost of breaking the norm, and this is the marginal benefit. So the stable equilibrium would be this proportion of people breaking the norm. But if I think that proportion of people breaking the norm is higher, then within this framework, it means I'm underestimating the marginal cost of breaking the norm. And then what happens is, little by little, people will adjust their behavior until the aggregate proportion of wrongdoers becomes higher. So if a lot of people are misperceiving the norm, they're gonna gravitate towards that misperceived proportion of people breaking the norm. And the same thing can happen in the reverse. If people underestimate the number of people engaged in this behavior, then the aggregate proportion of wrongdoers will gravitate towards the lower equilibrium. But in case of drugs and addictive substances, by and large, and I've been engaged in this research for at least the past 10 years, people tend to overestimate how many other people in their peer group, for example, are engaged in substance use. And this is, the overestimation is especially pronounced for illegal substances. So if you look at smoking, drinking, and marijuana use, the overestimation of people engaged in this behavior is the largest for marijuana use, because this is the most illegal drug among the smoking, drinking, and marijuana use. So marijuana use of peers is gravely misperceived by people and is greatly overestimated. And this is true in the data. Now, what is the source of misperception? Like in our case, we would be interested, is the source of misperception endogenous to the future outcomes or not? That would be a make or break fact for using our instruments to arrive at the causality. The literature on the causes of misperception is almost non-existent and sporadic, and it's mostly hypothesis of what might be driving misperception, but there are several papers that argue that normative misperceptions are induced by largely observing a few people engaging in extreme and unusual behaviors. Like if you see a lot of some freshmen or seniors in college drunk after the frat party, you think everybody is drinking. But that doesn't reflect the actual norm. The actual norm is usually pretty mild amount of drinking. Now, that's probably the major source when it comes to adolescents, just observing a couple of their friends or schoolmates engaged in these unusual behaviors. But media plays a big role too. Media usually fishes for eyes, and you cannot get a lot of views if you advertise normal behavior, because that doesn't make a sensation out of your story. What makes a sensation in your media story is some extreme behaviors, articles about some drunk drivers who are adolescents, or adolescents being caught smoking pot in the parking lot, stuff like that. And then this media coverages are amplified further by rumors. So that's how we think the bias is born, and we think it's a source which is exogenous to future health outcomes, which we're going to study in this paper. So when we look at our data in the last survey that we used to measure outcomes, we have 12,000 observations, 12,000 people. Back in 1996, so we observe our sample in 2016, 2018, when we measure the health outcomes. When they were young, 20 years earlier, about 15.6% of them are marijuana users. So we are talking about middle and high school adolescents. And then 20 years forward, the marijuana use is a little bit lower. These are the same people. But again, some of these people might have discontinued using marijuana, some of them might have picked it up during this 20 years. So we don't know that. Then 7% are regular marijuana users, which is approximately every week you use marijuana. Then out of 3 best friends, people report 0.7 friends are using marijuana. Among friends of friends, 15%, approximately 15% of marijuana users, which is consistent with the data reported directly by the respondents. And then in 2016, 19% have ever been diagnosed with depression, 20% diagnosed with anxiety, and usually depression and anxiety go hand in hand. They kind of reside in the same part of the brain. And then about 7% have experienced suicidal thoughts or attempted suicide in the past 12 months. So those are our 3 outcomes: anxiety, depression, and suicidal ideation. So we estimate instrumental variable model using 2-stage least squares. If we run the first stage, which suggests whether our instruments are strong or not, we find that when we restrict our analysis to using only one instrument, perceived number of friend users, as reported by the respondent. So one additional friend using marijuana translates into 20% more higher probability of you using marijuana. So all of this is happening during adolescence in 1996. So we get pretty strong instrument, which is nice. And when we look at the main effect, the instrumental variable estimates of the effect of marijuana use in adolescence on your future health outcomes 20 years later, so here we compare OLS coefficients to 2-stage least squares coefficients side by side, just to see if how much endogeneity there is, which biases our coefficients. We see that so OLS shows only anxiety is affected by your marijuana use in adolescence. Suicidal or depression are not affected. And then 2SLS shows that there is some action as far as suicidal ideation goes, but anxiety is really where the effect is. So if you use marijuana versus if you don't use marijuana as an adolescent. This causes you to end up with anxiety 20 years later, after we use the instrument. So this is the estimate of the causal effect. And this effect is about twice the magnitude of OLS. So I have about 5 minutes. Right. So we do a series of sensitivity tests and subsample analysis. So briefly, what we do is we divide our sample by gender. We discover that only females have increase in anxiety if they smoke, if they use pot as an adolescent, that not males. We test our instruments. We do placebo regressions where we estimate two-stage least squares models for outcomes which are unlikely to be affected by marijuana use in adolescents, such as height, parental socioeconomic status, health conditions that adolescents experience before they could have started using marijuana. Then we also gradually include our covariates to see how much unobserved heterogeneity could potentially bias our two-stage least squares estimates. Then we include both instruments at the same time, the perceived number of friends as well as number of friends who are actual users of marijuana. Even though those are highly correlated instruments, there is still some independent effect of each instrument on the outcomes, which allows us to include both of them without much concern about multicollinearity. And the reason why we include both instruments is mostly to test for exogeneity of instruments using over-identification restriction tests, and we pass over-identification restriction tests. Then we test the plausible violation of the exclusion restriction by allowing for the possibility that instruments might have a direct effect on the outcomes in the second stage model. What we do is we estimate the confidence bounds on the IV estimates using the method proposed by Conley in 2012, plausibly exogenous. This can be done using stata command plausexog. And the way we initiate our parameter for the direct effect of the instruments on outcomes in the second stage is by relying on the so-called zero first stage regressions, where you select a subsample from the main sample where you see that the instruments have no effect in the first stage, so the instruments are not valid. And then if we discover there is a effect in that subsample in the second stage, we use that the estimate of the direct effect of the instruments to estimate the bounds. So that's how it's done. Then we also change our definition of marijuana use in adolescents. We look at regular users, which we define as using at least 4 times, using marijuana at least 4 times in the past month, which is roughly the definition of CDC for regular using, which is once a week. And we get stronger effects, which is another indication of causality, because epidemiology, which has different definitions of causality and different methods to arrive at causality, suggests that if you have a dose response kind of effect, if you increase the dose and the response becomes larger, that's one of the indications of causality. And then we also implement an IV instrumental variable estimation, which is now two-stage least squares, to test the linearity assumption of two-stage least squares. We actually implement full matching estimation, where if you guys are familiar with the matching, like propensity score matching, what you do is you select 2 comparable sets of people, comparable based on pre-treatment variables like socioeconomic status back in the 1994. You select 2 comparable groups of people where the only difference is the instrument, the value of the instrument, whether you perceive or not perceive your friends to be users, for example. And then you compare the values of the outcomes between those two subsets of comparable people. And there is a statistic that you can compute which is comparable to two-stage least square statistic. So all of this sensitivity analysis support our main findings. If you're an adolescent, you use marijuana, you're gonna end up with anxiety, and that's only specific for females. Thank you. Do we have time for questions?
Yeah, we have, I think, still a couple of minutes for questions. So, yeah. Wait.
Could you please go up to the very beginning of the slide when you describe the age of the groups studied? This one. So I'm sorry, I maybe really messed up something here. Did you control for the possible fact that adolescents had some mental health problems before using marijuana? So they are using it because?
Right. We specifically excluded those from the sample.
Why?
Adolescents who reported, so we have a measure when you were diagnosed with anxiety and depression. We exclude adolescents who were diagnosed with those before we started measuring the marijuana use, so that we don't end up with the same anxious adolescents 20 years later.
But they might be held up when they get adult.
Right, that's a good point. So they might
They
still
might
give us some
report
juice in the
anxiety when
estimation.
they are adolescents, and then do not report anxiety when they are adult, although they use marijuana.
That's a great point. Yeah, we should include them. Then our effect disappears, and we won't be able to publish. Thank you so much.
Strange question, but in general, how many people in their 30s and 40s are depressed? So there are 20% of those who are like using marijuana, and in general.
Let me see if I have that.
Maybe I also missed it. But.
So, I'm sorry, can you repeat the question?
So marijuana users, there are 20% of them in their 40s and 30s are feeling depressed. No? No?
Among marijuana users,
Yeah.
how many are depressed? We did not look at that. But overall, in a sample, 20% are depressed in their 30s and 40s.
Okay.
But I can't remember when the last time I saw a pothead who is depressed. There's some anxious ones.
Like, I actually should go and read the paper, but just quick question. Why only 3, let's say, mental health issues were included? It's something from CDC?
That's pretty much all we had. And there were some other measures related to mental health. And those are not common.
Okay.
Mental health conditions, and they're really low percentages, so we didn't even want to look at those because we get into small samples and power issues.
Got it, thank you.